Thank you. So my co-author couldn't be here today, Tim Bonvechio. I don't know if you know Tim, but good buddy of mine and colleague from Georgia DNR. He was supposed to present today's talk, so if something doesn't make any sense or the slides look kind of wacky, blame Tim. Okay. All right. So, and the title has also changed a little bit. So, just to start off, of course, accurate age estimation is essential to properly calculating things like growth, survival, and recruitment. And of course, those things go into population modeling and informing management decisions. So it's critical that we age fish correctly. Unfortunately, validation studies are very limited in the literature, not only for fish in general, but for catfishes. And when I say validation, I'm not only saying validation of a particular structure for age estimation, but validation of various techniques. There's been a diverse variety of techniques that have been used to age fishes. And so when we consider validation, we want to consider both of those things. And I can't emphasize enough the importance of training programs as well as QA/QC programs that should be instituted by agencies as well as academia. And you can read more about those in Buckmeyer et al. In 2017. Oh, and by the way, there's Tim, if you know Tim or not, hacking away at a catfish. At this point, we all know that the lapilli otoliths are the preferred aging structure for catfish. They tend to be the most accurate. There are non-lethal methods. Folks still use pectoral spines to age catfish, and in some scenarios, pectoral spines are appropriate, particularly for species that are endangered or protected. Also, for populations where you're managing for a trophy fishery, you don't want to eliminate your really big fish. In some other situations, but the problem is with pectoral spines is as the fish get older, you run the risk of underestimating the age of the fish, right? So we're going to focus on lapilli otoliths. To get back to what I was talking about, very few validation studies have been conducted for estimating the ages of catfish. There are only a few out there. Of course, Buckmeyer et al. From 2002 validated a technique for using lapilli otoliths for channel catfish. That's through age 4. And since then, a few validation studies have been conducted where otoliths have been validated as a structure to estimate the daily age of young of the year fish. However, validation studies, unfortunately, are still pretty scarce in the literature, and that's a problem because we want to ensure that we're collecting reliable age data. So I'm going to briefly mention the Buckmeyer technique. A lot of you have already used it at this point. We're going to refer to it as the grinding method as described by Buckmeyer, adapted from previous methods. And so we're all pretty much aware with the technique where you take the otolith, you brown it on a hot plate, you stand it upright in crystal bond with the crystal bond molded around the otolith, with the anterior rounded edge pointed up, the posterior edge pointed down, straight up, perpendicular to the slide. And of course, we gently grind down that otolith into the core. And once you see the core and the rings, of course, you're ready to go. And this would be the validated method. This is the technique and, of course, the structure that was validated through age 4. Now, since that technique has been described, a number of rogue scientists like myself have altered this technique and modified it to use sectioning methods and a variety of other methods. The problem there is now you're altering the technique that now needs proper validation, right? And these are things that you really need to consider when you're aging fish. And so the techniques for sectioning go back to techniques that are used for centrarchids. Bonvechio and Allen et al. In 2003, sectioning methods for centrarchids, who, by the way, their otoliths are much prettier, right, than your catfish otoliths. Specifically with the sectioning method, there are a variety of different techniques that have been employed. Some take a thin section of the otolith. Other techniques that employ the sectioning method will mount the otolith and bed the otolith in a clear epoxy resin with the round posterior edge pointed to the right. The rounded anterior edge pointed to the right, the pointed posterior edge pointed to the left. And then you basically take your high precision sectioning saw, take a cut through the core, and for our technique, you'd make another cut, but through clear resin, past the posterior edge to release the block from the saw, and then gluing that otolith embedded in the resin in an upright position, very similar to the method described by Buckmeyer. Okay, so the sectioning technique I'm going to be presenting today is the one slice method, not producing a thin section. And so, as far as we know, there have been no studies that have tested the sectioning method against the grinding method. And it's kind of funny, I think Jason Olive was talking at the start of the meeting saying how the catfish meetings are a good place where you come up with ideas. Tim and I actually came up with this idea in 2010. So it's been about a decade since we decided to do it, okay? Oh, and the other thing we also wanted to consider was the time, resources, and costs associated with each method and do a comparison there. So the objectives were to obtain age samples for all your three main catfish species, the blue catfish, the game species, the blue catfish, the channel catfish, and the flathead catfish, the species that are aged most frequently. Of course, we'll eventually extend this to bullhead species and other species as well. We wanted to apply the two processing techniques. Both have been published. Validated grinding technique against the non-validated sectioning technique. We wanted to compare precision between the two techniques, as well as readability, which we assessed via confidence, and also compare the costs and effort associated with each technique. All the fish were collected in southeast Georgia. The blue catfish were collected from the Altamaha River. I should mention that the blue catfish population there is highly invasive, and they're a really fast-growing population in terms of their body growth. For the flatheads and the flathead catfish, they were obtained from the Satilla River, which is in southeast Georgia. The flathead catfish population there, of course, is an invasive population. Again, fish that grow really fast. And then the channel catfish population is a naturalized population that's been there a really long time. And they grow relatively slowly, at a pretty slow rate. So following methods that have been well described in previous literature, of course, primarily using a hacksaw to cut into the brain. Of course, it's not a job for the faint of heart, right? You have to be willing to get dirty and mucky and nasty to do it. Extract the otoliths, dry them, clean them, dry them, store them in coin envelopes. We processed each otolith of a pair by each method. Each otolith section was read by two experienced readers. So Tim would do one read, I would do the other read. We would assign our reads a confidence level. That confidence reading was based on a Likert type scale ranging from 1 to 4. 1 would be little to no confidence in our read. 4 would be complete confidence in our read. And that was based off a published study by Spiegel. We also timed each step of the process to assess effort, right? Because now that natural resource agencies are trying to streamline the process and save time and money, we wanted to assess effort between the two techniques and consider that also as a factor. So for methods, we assessed precision between readers by percent agreement with a 95% confidence interval. We also conducted pair t-tests because we had paired samples, and we compared reader confidence and processing techniques for each species, as well as comparing age estimates between each technique for each species. Age bias plots were constructed to assess potential bias between the two methods, as well as reader bias, the presence of potential reader bias for each processing method per species. We estimated effort over time, and we did that per 100 otolith sample. So I don't know about you, but we like to think a sample of 100 is a nice number, right? So 100 was our nice even number to give you an idea of what a sample of 100 otoliths would take in terms of time. And we also expressed that in the number of minutes per otolith sample. And then we went into, I went back to a whole bunch of vendor quotes that I received and also online vendors. And we put together startup costs that would be required to start up a lab, as well as the consumable supplies that would have to be ordered over time. And so let's go ahead and get right into the results. So for channel catfish, the grinding method was best in terms of percent agreement. Percent agreement for the grinding method was really good. It was 95.7%, with the disagreements only being 6 of them, differing by just 1 year. The sectioning method performed relatively poorly in terms of percent agreement. It was only 66.7%. Now for other structures, I've seen other structures having worse agreement, but the majority of the disagreements were within 1 year. So it wasn't terrible, The issue with that is with the sectioning method. I'll talk about that a bit more at the end if I have time. But with the channel catfish, with the sectioning method, oftentimes it would be difficult to determine where that first ring formed. And that's why they were often off by 1 year. As far as confidence, we were significantly more confident in our reads with the grinding method described by Buckmeyer, and not so confident in our sectioning reads overall. Now the ages, this was an issue that we may have to contend with here, but the age ranges assessed with each technique differed. So with the grinding method, we estimated the ages of channel catfish ranging from 1 to 10 years. With the sectioning method, our ages range from 2 to 15. Okay, so that's a problem. The other thing is our mean age estimated with the sectioning method was significantly greater than with the grinding method. And the grinding method underestimated sectioning method ages at ages 3, 6, and 7. So if you take a look at the plot here, you've got mean estimated age in years for the grinding method, and that's plotted over the given age for the sectioning method. These bars represent 95% confidence intervals as described by Campagna. And basically, the idea is if the 95% confidence intervals do not overlap with the one-to-one line, that would indicate either underestimation or overestimation. And you can see at ages 3, 5, and 7, you're getting some underestimation of age in comparison to the sectioning method. This is not using known age fish, so we're not measuring accuracy here. We're measuring the agreement between the two techniques. Really big confidence intervals for ages 4 and 5, inconclusive there because the data set just happened to be very limited for those age groups. So there you go. Okay, there's an example. There's the 15-day-old channel catfish. Tim and I aged that fish both at age 15 with high levels of confidence, ranging from 3 to 4, an average of 3.5. The same otolith that was aged with the grinding method was aged at 10 and 11, an initial disagreement with low confidence. So one thing we did notice is when the channel catfish otoliths were sectioned correctly, they were pretty. I mean, they showed the rings popped and they were easy to age. As far as reader bias, no reader bias for the grinding method, and then little to no bias for the sectioning method, really at age 9, but that was inconclusive again because there were only 2 data points at age 9. There's a little bit of underestimation of age by reader 2 versus reader 1 at age 4, but pretty good there that there's really limited to no aging bias for both methods for channel catfish. Moving on to flathead catfish. The story was a lot different for the flatheads. Percent agreement with the grinding method, still really good, 96.3%. But the percent agreement for the sectioning method was quite a bit better compared to channel catfish, at 89%. And those disagreements differed for the most part by only 1 year. That's 76% of those that we disagreed on. And on top of that, and this is where things get interesting, we were significantly more confident in our sectioning method versus the grinding method. The average confidence was 3.335. Solid confidence for the sectioning method. The grinding method confidence level was a 3.07. Still good, but not as good as the sectioning method. Good news as far as aging goes, though, for both methods, we estimated the ages ranging from 1 to 11, so there was complete overlap there. Problem being is that the mean estimated age with the sectioning method was 5.54, significantly greater than the mean estimated age with the grinding method, so there is a difference there. The other issue is consistently past the age, from age 6 through age 10, the grinding method is consistently underestimating the ages assessed by the sectioning method. All along there, you can see for those older flatheads. Pretty consistent within about or right around 1 year underestimating the ages. And so when you're doing things like trying to estimate recruitment, if you're off by just 1 year, that's a problem. Now, with that being said, this is not necessarily saying that the grinding method is underestimating age. It could be that the sectioning method is overestimating the age by 1 year, and we wouldn't know that unless we have known age fish, which I'm hoping to steal from somebody I know. Okay, as far as reader bias, there was absolutely no reader bias for flathead catfish for either method. The lines are basically right on top of that 1-to-1 line. For blue catfish, Similar to the Flathead Catfish, 98% reader agreement, 93% reader agreement for the sectioning method, much closer. We were significantly more confident in our reads with the sectioning method versus the grinding method, but I don't want to knock on the grinding method too much because the confidence for the grinding method was still good, 3.11. As far as the ages were concerned, complete overlap, 1 to 6 years with both methods. Again, our ages estimated with the sectioning method were a little bit greater than with the grinding method, and we did underestimate the sectioning method ages by way of the grinding method at ages 4 and 5. At 6, inconclusive due to limited data, okay? And as far as reader bias, there was no reader bias at all between the two techniques. How much more time do I have? 5, awesome, okay. And so there was no reader bias at all for either technique, as you can see there. All right, so, okay, and then finally effort. Effort was kind of interesting because effort was greater for the grinding method for 2 species, for the sectioning method, but it was greater for the grinding method for the others. So there's a lot of information on this table, but just go ahead and focus on the numbers at the bottom. For channel catfish and blue catfish, it took 12 and a 9.4 minutes respectively to process 1 otolith using the sectioning method, compared to only 10 and 7.8 minutes with the grinding method. However, if you compare that to the flathead catfish otoliths took 2 minutes more on average to process compared to the sectioning method. So all in all, the effort was actually quite similar. And that's not what I expected, because when you consider all the steps of the sectioning method, they actually end up being quite similar. The reason why the grinding method took longer for the flathead catfish is you have older fish with larger otoliths, which take more grinding. Okay. As far as costs go, I'm just gonna kind of gloss over this, but long story short, it's significantly more of a cost to perform the sectioning method because you have to purchase a high precision sectioning saw as well as other things. You'll actually have to look for the paper because we itemized every single thing that you would have to order to do each thing, but it looks like, about $7 more grand it would cost to do the sectioning method. And so with a little bit of time left, let's wrap it up, do a quick recap. Percent agreement was overall good for both methods, for blue catfish and flathead catfish. We think that has something to do with how well they're growing and how fast the otoliths are growing, distinguishing between slow and fast growth zones of the otolith. Percent agreement was slightly lower for the sectioning method. That's because we could talk more about this later, but the sectioning technique takes especially great care in lining up that blade. If you don't line it up correctly, you're liable to miss the core. And if you make your cut too far posterior to the core, if you miss the core, then you're going to have a shoddy otolith section. So when the cut is made right, though, the sections are beautiful. I mean, Tim would say that whenever we'd have a pretty section, he's like, "Oh, that section's pretty," right? For channel catfish, low percent agreement for the sectioning method. That's because we think that the catfish were really slow growing. Smaller otoliths, smaller cores, more likely to miss the core when you make your slice. Long story short. I wish I had more time to talk about it, but I can. Confidence, again, is probably related to that. That's why we're probably more confident in our reads with the flathead catfish and blue catfish versus the channel catfish, because of that issue of slow growth with the channel catfish. And then finally, underestimation of age is something to consider against known age fish. Hopefully, if we can get some known age fish or use some other means for testing it against some other technique for validation, we can truly see which technique is actually truly getting closer to the actual age. As far as any recommendations, long story short, I don't know what to tell you. The grinding method is still appropriate and probably even more appropriate for the channels. The sectioning method worked really great for blues and flats, and we're more confident in those reads. But one method did not fully separate itself from another. And so future research has to look into issues, like I said, with the underestimation of age and testing them against known age fish. And I think I'm pretty much done, right?
Yeah.
Okay. All right, so there are some advantages and disadvantages of each method, so we could talk about that later if you catch me in the hallway, although I'm catching a flight in about 4 hours, so that may not be possible. Okay? All right.